Hi, it's Carly McAvoy. This is my fourth video for the logic packet. We ended here. So in this case, I'm going to start talking about truth tables, and it's a way to set things up, whether we're talking about negation or conjunction or disjunction for these. We're going to make a truth table and decide the truth value of certain statements. So very easily for a truth table for negation, which is the not, it has the opposite truth value from the statement. So if I have a statement, let's say P, if P was true, the negation is false. And if P was false, the negation is true. That's basic truth table for negation. What about for conjunction? Well, a conjunction is only true when both statements are true. So if I have two statements, P and Q, if they're both true, then the statement is true. If one is true and one is false, it's false. One is true and one is false, it's false. So the only time you see a true for a conjunction is if both statements were true. What I want you to notice here is that if I have one statement, I have two options. If I have two statements, I have four options. If I have three, I have 8. And hopefully you can recognize that 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. And if you want to know how many different statements or different groupings you're going to have under here, this power right here is a number of statements that you have. So for 3 statements, you have 8 different possibilities. The other thing I want to point out about this is that there is a pattern here. The P, we always put true, true, false, false. And then Q always goes true, false, true, false. Okay, let's look at a disjunction. So a disjunction is the or statement. And in this case, we're saying we have true, true, false, false, and true, false, true, false. That stays the same. But what about P or Q? Well, in the or statement, we're only interested in when do we have one of them to be true. I could have this one or that one. So if one of them is true or both of them is true, then this is a true statement. The only time you get a false statement for a disjunction if both your statements are false going in. Okay, what about an example of given statements decide on the truth value? Well, we could put these into the chart table, or maybe we don't need to. But what we know here is P is 10 is greater than 4. That's originally got a truth value of true. And Q is 3 is greater than 5, and that's got a truth value of false. So what is P and Q? Well, P and Q is when we have to have both true to get true. And there's one true and one false. So this has a truth value of false. What about P and not Q? Well, if I do not Q, P was true already. And since Q was false, not Q is true. And so that gives me a true statement overall. What about P or Q? Well, as long as one part is with the or, as long as one part is true, it's true. And over here, not P or Q. Well, this was true, so not P is false. And we already knew that Q was false. This is the one time when we can't give that a true, because in an or statement, one of them at least has to be true. So this one's going to be false. All right, so that's how you're going to decide as you're doing those. Well, we want you to construct a truth table. Again, we want to construct a truth table for not, or a negation of P and Q. Well, to do that, we always want to start with our 2 columns. And I'm showing you again, the P statement is going to be true, true, false, false. And the Q is always going to be true, false, true, false. That's always the pattern. So that's there. And then we have to go through and decide which one of these. Well, remember for an and statement, we only have a true if they're both true. And this is where they're both true in that first column. In the rest of them, we have one true and one false. So there's that. Now, I want to build a truth table for the negation of that. So what I do in my truth table, and I've kind of done it in parts, is to say I start off with the P and Q statements, and then I make my P and Q, which I just did, true, false, 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 and then I negate that because I'm saying the opposite of whatever I got there. And that makes false, true, true, true. It just makes it false. So for example, Harvard is a college, Yale is a college. Those are both true. But not P and Q. It is not true that Harvard and Yale are colleges, but that's not true, right? So the compound statement that's always true is called a tautology. Is this a tautology? No, because there's one case when that's false. So this is not a tautology. All right. Knowing how to build a truth table means that you know what these symbols mean. You know negation, you know and, both statements must be true for it to be true. All other cases are false. And or, both statements must be false for it to be false. All other cases are true. Now the conditional is a little harder. We'll talk more about it. For a conditional to be false, the only way you can get a false conditional is if you have a true followed by a false. The first statement has to be true followed by a false. All other cases are true. We'll talk about that a little bit. But the way to think about it is if I say, if you study, you will get an A. Well, if you study and you get an F, then I lied, right? You studied, but you didn't get the grade I said you would get. That's not true. But if you don't study, then all bets are off. It doesn't matter what you get over here. If you don't study, you didn't do what I told you to. So my statement has to be assumed to be true. So if you don't do the first part, if the first part's not true, then everything else is true. And of course, if you study hard and you get the grade I promised, then I was true also. So the only time you can get a false is if it's true on the first half and the antecedent, but the consequent is false. That's the only time. Okay. So we want to build a truth table to give us the truth value for that statement. So what I know is I have a P. I need to do something for P. I've got a Q. Do I have a not P in there? No, so I don't need to put that in there. But I do have a not Q. That has to be in there. And then I have this thing in parentheses. So not Q and P needs to be in there. And then P implies not Q and P. So that's my headings that I need in order to build that truth table. So bringing that up to the next page, fill in the truth table. So I'm going to have what I just said, P and Q and not Q. I don't know what I just said. There it is though. Not Q and P, and then P implies not Q and P. Okay, so there's 4 lines here because I had 2 statements, and I know I always have 2 to the second or 4 statements with 4 lines with 2 statements. So I'm going to have true, true, false, false, because that's what I always do. And I'm going to have true, false, because that's what I always do. Now, not Q is just the opposite of what Q was, so that's going to be false, true, false, true. So those columns should be easy. And now I'm looking at not Q and P. So I don't care about Q. I'm looking at these 2. And this is an and statement. And what I know about and statements is you can't have a true unless they're both true. So this is going to be false. Here I do have both true. No. And no. So I have 1 true and 3 false. And now I'm going to use that to answer this. P implies not Q. Now here's what I want you to remember. True to a true is true. True to a false is false. That's the only false. False to a true, that's true. And false to a false, that's also true. And again, you're like, what? How can all those be true? Remember, the only time you can say that my statement was false is if you did what I told you to, but you didn't get the outcome that I told you you would get. If you did what I told you and got what you expected, that's true. If you did what I told you, but you didn't get what you expected, then I did not tell you the truth. But if you didn't do the first half, you have no way of assessing my truth. So you have to assume that it's true. Okay, so P implies this. So P implies this. So here, P was true, but this part was false. That's the only case, right? That's where we can't say that was bad, because you did what you were told, but you didn't get what you were expecting. True followed by true, well, you did what you were told and you got what you wanted. Perfect. Here and here, see how these are both false? It doesn't matter what comes after that. They happen to both be false. But you can't assess the truth of my statement, so you have to assume that it's true. Okay, one more thing, and then we'll go on to an 8-table one, is construct this one. The truth table for not P or Q and not Q. Always you're going to have P and Q, and I've just gone ahead and written those in for you. I'm going to come back in a few minutes and show you the answer to that. But write it down and see if you can fill it in. Of course, you don't get better at it just by watching me. And that'll be where we start our next video. All right, have a great day.